What is a bond? Do you know? What is a bond? Who buys the bond? Who sells the bond? Do you know? You know how you take a loan, when you take a mortgage, you take a loan from the bank and you pay back the bank level payments per month or per year? This time, it is the institution that is taking a loan from you. So you are giving them the money. They are going to pay you back monthly payments. Those monthly payments are called coupons. So when you purchase a bond, it is a contract with the person who is issuing the bond, usually some government agency, and that government agency is promising to pay you payments, level payments, throughout the term of that loan. Plus, it will pay you a large amount of money at the end of the term of the loan. So let me get some paper here and let me start making some timelines so you can see what's going on as we read, okay? A bond issued by a government entity is a security which promises certain payments on due dates. Bonds are usually low-risk investments since the bondholder is promised certain payments at certain times. The date of issue is the date when an investor loans the bond issuer the money by purchasing the bond. So we start at time 0. The maturity date or redemption date is the date of the last payment on this bond. So here's a coupon at time 1, and here's a coupon at time 2, and I need to lower this volume. Give me one more second, please. So I have coupon payments at 1 and 2 and so forth, all the way to the end. Let's say N coupon payments. So the maturity date or redemption date is here, and at the redemption date, not only will you receive a coupon, but you will also receive something called C, which is the redemption amount. So this total payment is a balloon payment, right? Every other payment is level. This is a balloon payment. A balloon payment is a final, large, extra payment. So let's see what it says here. The maturity date or redemption date is the date of the last payment on this bond. There will be a coupon payment as well as, let's fix that, as well as a redemption payment at this date. So the balloon payment is equal to the coupon plus the redemption, which is called C. A non-callable bond is a bond which has a fixed maturity date. So for the first 10 days or so, we will only talk about bonds which are not callable, meaning that the way you see it here is the way it's going to happen, and it's only going to end at N. And the person who issues the bond cannot say, oh, you know what, the deal is off. I'm going to stop giving you coupon payments, and I want to pay you off right now with the redemption at some time in the middle. That cannot happen if it's a non-callable bond. But if it's a callable bond, then the government agency has the right to say, I don't want to continue with this process. That would be equivalent to when you take a mortgage and you say to the bank, I don't want your mortgage anymore, I'm going to refinance. This is the same situation where they might say to you in a callable bond situation, I'm done with this arrangement, I'm going to give you your last coupon and I'm also going to give you the redemption, and I'm done. Somewhere in the middle here. But that's not possible right now, okay? This is the initial theory. So a non-callable bond is a bond which has a fixed maturity date. Our maturity date is right here. Callable bonds, on the other hand, may be redeemed at dates prior to the maturity date. We'll talk about that later. A bond that pays only one payment at the maturity date is called a zero coupon bond. So a zero coupon bond has no coupons, that's all. And the redemption is the only thing you get back at time N. Zero coupon. Nothing is happening at time 1 and nothing is happening at time 2 and so forth. But at time N, you will get your C back. A coupon bond, on the other hand, promises a sequence of coupon payments prior to as well as on the redemption date. The coupon period is the period of time between coupon payments. So they could be monthly, they could be quarterly. Okay, so basic price formula. So this is called alphabet soup. There's just lots of letters running around. You need to understand what each letter is. So F is the face value or the par value of the bond. F is the face value. Now this face value, it's not equal to the price, and it's not equal to the redemption necessarily. So why do we need a face value? We need a face value to determine what the coupon payment is. So this is needed because the coupon payment is equal to F times some rate R. We're going to get to R in a minute. So the coupon payment is going to be F times R. So I need the face value of the bond for that. Now, when you purchase a bond, the face value is the number that's stamped on the front of the bond. So if it says $100, that's a $100 face value bond, okay? This is not necessarily the price of the bond or the amount received at maturity. It is only used to calculate the coupon payments. The coupons are calculated based on nominal interest rate alpha M convertible M times per year. So this alpha M will be given to you in every problem. Given in every problem. Your job is to do this. R equals alpha M over M. So this is the coupon rate per coupon period. So they might say something like, the coupon rate is 6% convertible 4 times a year. So that's not going to help you because you want to figure out the coupon payment, and the coupons are happening 4 times a year, so you want that 3-month rate. And you will do that by taking alpha 4 divided by 4. So that's what I mean by this. And then you take that R and you put it in here and multiply it by FR to get the amount of each coupon, which you see up here. Are you following me? Okay. So let's see. Where are we? The coupon period is the period of time between coupon payments. Okay, so the basic price formula. So look what's happening here. I have a coupon of FR here and a coupon of FR here, and this continues. Now, N is the number of years that the bond is held, and M is the number of coupons per year. So now there's this lowercase n, which is the total number of coupons, which is just N times M. Does that make sense to you? If this goes on for 6 years and it's happening 4 times a year, there will be 24 coupon payments. That's what I'm trying to say. Okay, so the basic price formula, I'm here. F is the face value or the par value of the bond. This is not necessarily the price of the bond or the amount received at maturity. It is only used to calculate the coupon payments. The coupons are calculated based on a nominal interest rate alpha M, convertible M times a year. Let M be the number of coupons paid each year. We did all this. R is equal to alpha M over M. Be the effective interest rate over a coupon period. F is the face value, blah, blah, blah. This is all done. FR is equal to F alpha M over M. N is the number of coupon payments. C is the redemption. And I'm ready to talk about a basic price formula. Let's do it. So let's create it right now. If I have a coupon at time 1, I'm going to pay some price here for this bond. A coupon at time 1, a coupon at time 2, and this goes on for N periods, where N is equal to N times M, capital N times M. That's the number of coupons. And I have a FR at the end here, and I have a C at the end here. Can you help me come up with a time zero equation of value such that I can find the price of this bond? Just using what you already know. How do we normally do? Don't we do like this? Let's take all these, bring them back. All of them, right? That's going to be an annuity of FR. And then I have this C payment, which also has to come back, right? So let's go. Can you write me an equation? Sorry? FR. I'm taking present value. A angle N. At some interest rate, let's say J. Okay. Plus C. Minus N. Right, so C Vj to the N, where of course Vj is equal to 1 plus J to the minus 1 power. And this minus P plus this equals 0. That's the time zero equation. Does that make sense? So they call this franc in order to remember it. F-R-A-N, and then they call this mess K. And they say P equals. So P equals F-R A angle N at some interest rate J, which is per coupon period. So we'll have to, if they give us some weird interest rate I, we'll have to convert it per coupon period depending on how many coupons there are in a year, plus C, 1 plus J to the minus N, and I'm done. I brought the P to the other side. So that's the price formula. Follow me? It makes total sense, right? It's just an annuity of FR plus a final redemption amount. God bless. Any question? So then there's something else to think about. Let's see, where are we? Coupon payments may be expressed in terms of the redemption amount. With this in mind, the modified coupon rate G can be computed. So let's talk about this equation. FR equals CG. So FR, of course, is just the coupon, the amount of the coupon. And G is called the modified coupon rate. In relation to C this time, in relation to the redemption. After all, the person who is buying this bond, who is the investor, is interested in the redemption, right? I'm interested in how much are you going to pay me level payments and how much are you going to pay me at the end. So I'm interested in a yield rate, G. Actually, it's called, I should not call it a yield rate, I should just call it a coupon rate. But in terms of C, the redemption, so this is FR over C. How much are the coupons in relation to the final redemption? That's the question. And that's G. So FR equals CG. And then it talks about J. So if they give you I is the annual effective interest rate, which will be given in your problem, your job is to figure out the J that goes with that, because of course your stuff is happening M times a year, so you cannot work with this rate I. So you would say 1 plus J to the M is equal to 1 plus I, because your coupons are M times a year. You need the rate for M times a year. So that's what J is. So yield rate per coupon period. Okay. Next, it says FR equals CG is also equal to GJ. Let's talk about that. FR, that's the coupon, is equal to CG. As we know, G is equal to FR over C, is equal to GJ. So G is called the base amount. So G is equal to FR over J. Why don't I look at that as a perpetuity? Look at this. This is equal to FR times 1 over J. So G is the present value of a perpetuity of FR. Since I know that the present value of a perpetuity is equal to 1 over the interest rate, so this is present value for perpetuity of FR payable forever because it's a perpetuity. So these payments, of course in my situation, these payments are not happening forever, but this G is in the case of them happening forever. So payable forever. And later on, this G will come in handy when we start talking about other formulas, premium discount formulas and others. Okay. So here it says G is the base amount and represents the coupon in terms of effective yield rate per coupon period. G is the amount you would invest now to create a perpetuity immediate paying coupons of FR forever at interest rate J per payment period. So that's important, right? Present value of a perpetuity of FR at J per coupon period. Are you understanding me so far? Let's go to the next page. Well, first let me make sure that I like to do my own thing, so let me make sure that everything here is covered. Yeah, we're good. Next page. So this, of course, should be memorized. You're going to use this all the time anyway. FR equals CG equals GJ. So what do we have here? We have the face amount. We have the coupon rate R per coupon period. We have C, which is the redemption. We have G, which is the modified coupon rate. Then we have G, which is the base amount. And then you have J, which is the yield rate per coupon period. Okay? The bond's price P is a function of the bond's cash flow. We've already done this. It's coupons plus the redemption, and its yield rate. P is the price to be paid for the bond, allowing the investor an effective yield rate J per coupon period. The bond's redemption payment is separated from the final coupon during the valuation process. Yeah, we saw that, right? The final FR, this final FR payment, this final coupon payment was included in the annuity. The redemption was not included with the annuity. So that's what they're saying, that we separate out that payment. Using the time zero equation of value, we can obtain the basic price formula. We've already derived this. P equals FR A angle NJ plus CVJ to the N. So let's go do an example. An 8-year, N is equal to 8, $3,000, F is equal to 3,000, it's a face amount. 10% bond with semi-annual coupons. So alpha 2 is equal to 0.10, and alpha 2 over 2, because I'm interested in the semi-annual coupon rate, right? Not in the nominal coupon rate convertible semi-annually. So alpha 2 over 2 is equal to 0.05. That's my coupon rate per period. With semi-annual coupons and redemption value 2,800, C equals 2,800, is bought at a price which yields the investor an annual effective yield rate 12%. I is equal to 0.12. Find the base amount and the price of the bond. So the first thing is I need J. I cannot work with I because my coupons are semi-annual, but the yield rate they gave me is annual, right? So can you go find J right now? How would you find J? What do you think? All I want to do is convert I to J, where J is the semi-annual rate, I is the annual rate. Can you help me? Shimran? What do you think? All I want to do is convert this one to a 6-month rate. Don't we know how to do that? Go, Matthew.
So 1 plus J
squared.
8.
Why 8, love? 2, yeah, squared. Equals 1.12.
Yeah.
Okay, so 1 plus J equals 1.12 to the 1/2 power. So it's going to be something just less than 6%, right? How much is it? Let's see. Can I cheat? So it turns out to be 1.0583. Therefore, J is equal to 0.0583. Okay. So now I can find the price of the bond, right? Shall we draw a timeline? This happens for 8 years, twice a year. So this is going to be 16 is equal to N is equal to N times M, which is 8 times 2. Start at 0. At time 1, I have FR. This is R right here. The coupon rate per coupon period. So 3,000 times 0.05, 150, right? 150, 150, 150 happens all the way here, plus C also happens here, plus 2,800 at the end, at time 16. Okay, so price. What's the price equation? Can we take the present value of all this mess? David?
So
take present value like this. Boom, boom. It's an annuity, right? Use this price formula right here.
so it would be 3,000 times 0.05.
Right, I did that, and I got 150. Let me write that. FR is equal to 3,000 times 0.05, which is 150. So that's every coupon payment is 150. Right? That's why I put a 150 here. So let me make this an annuity. Let's go. Price equals what?
150.
Right. A 16 angle 0.0583. Plus
Plus
the last payment.
2,800 times times 1 plus 0.0583 to the 16.
Minus 16, right?
Minus 16.
Because you want to discount, right? That's it. That's the price formula. When you clean that up, you get 2664.61. Immediately after you find the price, you should make a mental note as to whether the price is bigger than the redemption or the redemption is bigger than the price. Okay? So in my case, the price equals 2664.61 and the redemption is 2,800. So the price is less than the redemption. And therefore, the bond is bought at discount. Therefore, the bond is bought at discount. So I'm laying the groundwork now for like 2 classes from now, okay? Just to keep you focused on P versus C at all times. Bond is bought at discount because P is less than C. Okay, what else did they want? Find the base amount. What is the letter for the base amount? Right, G. How should I do? What's that equation that we have to memorize? It's right up here. So FR equals CG equals GJ. I'm looking for capital G. So capital G is the amount you would need now in order to receive coupon payments forever. So FR divided by J. That's not so hard, right? FR is 150 divided by J, 0.0583. When I do this, what did I get? 2572.88. 2572.88. This is the amount you would have to invest now to have a perpetuity paying 150 forever. At interest rate J per 6-month period. Is there anything that I've said that bothers people? Please ask me. Covered everything here. I have covered everything there. Any issues? So you're allowed a cheat sheet, right? 3 by 5. The price formula should go on the cheat sheet. This should go on the cheat sheet. And of course, FR equals CG equals capital GJ should go on the cheat sheet. Next one. A 12-year, let me just move this over so I can continue to write. 12-year, $2,000 face amount, 8% par value bond. A par value bond is a bond where F is equal to C. So immediately they're telling you what C is. Par value bond means F equals C, which is 2,000. %8 par value bond. So this 8% number with quarterly coupons, 8% is the nominal rate, 0.08 is equal to alpha 4. Because it's saying it's an 8% bond with quarterly coupons. So they're giving you the nominal interest rate convertible quarterly. So immediately I'm going to go alpha 4 over 4 is equal to R, which is 0.02. It's the coupon rate per coupon period. Is bought for $2,200. Price equals $2,200. Is this a discount bond or not? You want to be able to recognize immediately, right? So this is P greater than C. So it's not a discount bond. This bond is bought at premium. Find the effective yield rate J per coupon period. Then find the APY I, and then find the nominal rate capital I convertible quarterly. Okay, we can do this. Give me a formula, please. I have a price formula, right? P equals FR, A angle NJ, plus CVJ to the N. So, can you help me? What is FR? FR is equal to 2,000 times 0.02, which is 40? 40. Okay, so the price is 2,200 equals 40. A angle what? This goes on for 12 years, 4 times a year. Right. So let's write that somewhere. Little n is equal to n times m. That's the total number of coupons. So that's 12 times 4, which is 48. So 40 A angle 48 J. J is what I'm looking for. Plus C, $2,000, 1 plus J to the minus 48. So this has to get solved on some calculator. Would you like to go try that right now? And we better put the formula in for this one. 40, 1 minus V to the 48 over J plus 2,000, 1 plus J to the minus 48, and then that's 40 over J, 1 minus 1 plus J to the minus 48, plus 2,000, 1 plus j to the minus 48 equals 2,200. And this has to get solved. When I do solve this, I get j is equal to 0.0169395. Now this is a how many month rate? It's a quarterly rate, right? So 3-month rate. So let's call this j 1/4. I don't want j 1/4. What do I want? Find the effective yield rate j per coupon period. Yeah, that I did. Then find APYI. So what do you say? How should I do? How do you go from a 3-month rate, i.e. a quarterly rate, to an annual rate? One plus I equals what? One plus j 1/4 to the 4th power. Because there are 4 of those periods, so I'm compounding 4 times, right? Is equal to 1.0169395 to the 4th. So let me see what I get. 1.069499. 1.069499. Therefore, I is equal to 0.069499. Annual effective interest rate. And the next thing they wanted is find the nominal rate I convertible quarterly. So this is J4/4, right? J4/4 is J 1/4. And I'm looking for J4. Therefore, J4 is equal to 4 times J 1/4 is equal to 4 times 0.0169395. And then you get 0.067758. That's equal to J4, which they want to call I. Get me? Any issues? Would you like to try the next one yourself? You try, okay? This time they want you to find C. If I asked you right now, is it a discount bond or a premium bond, could you answer me? Exactly right. You cannot answer until you find C. Right? F is not going to help you. You have to compare the price to the redemption. Just making my point, okay? 16.80. Four, 3, 4, 2. Yeah.
30 cents, like, as well.
Yeah. 4342.33. 4342.33. So for this one, P equals 4986. So P is greater than C. Bought at premium. Let's talk about the next formula, which is the premium discount formula. It's just manipulating our price formula. So here's the price formula. P equals FR A angle NJ plus CVJ to the N. So let us take this VJ and substitute. So let's cross multiply. I know that A angle NJ is equal to 1 minus VJ to the N over J. Cross multiply. J A angle NJ plus 1 minus 1, minus 1 is equal to minus Vj to the N. So Vj to the N is equal to 1 minus J, A angle Nj. So I solved for Vj to the N, and I'm going to go put that in here. So P equals FR A angle Nj plus C 1 minus A angle Nj times J. So let's clean this up. FR is also equal to CG, right? So let me replace right now. FR is equal to CG, so P equals CG A angle NJ plus C minus CA angle NJ times J.
Professor, can you pull the paper up a little?
This way?
Oh, yeah.
So P equals C, pulling out the C from here and here, G minus J, A angle NJ plus C. This is an alternate formula for the price. And it's called the price, a premium discount formula. Price formula, alternate. Premium discount. So depending on what they give you, sometimes they give you C and they give you little g and they give you little j, and you can just plug in and be done. Okay, so I think this is a good place to stop. We'll just keep going, plugging along in this as we go on. Do you want me to post more new homework now, or do you want me to wait?
You always post it. Just push it like that.
Yeah, let's start with, I'll just post it for this beginning portion, right? Homework is due Friday. I already changed the date, just so that it's not like all panic, because I understand that there's all kinds of exams this week in other classes. But since you just learned this and it's fresh, you should go do a couple of problems from and I'll post them right away tonight, okay? Have a good day, folks. Hi. Started bonds today.
Oh, easy. Yeah, bonds is a lot easier than appears materials. Because basically bonds are basically like signifying the monetization loans. And
Yeah, yeah.
Like as long as you get those.
Hi. Yeah?
At the first time, I just plug in this I directly into this
No,
formula.
cannot.
Yeah, because
This is
it's,
annual.
So because it's semi-annually, so we have to convert this into this J, right?
Correct.
So what if it's annually, like every year?
Then you would use it.
Oh, we
Then
can
you would
just
use it
this one.
directly.
Okay,
Yeah.
thank you.
So however many payments, whatever the payment period is, you want the interest period to match. So if it already matches, great. If it doesn't match, you have to convert it.
I still remember the time that asked what's annual factor and what's annual rate. Remember?
Yeah.